Good morning, my dear students. Today I am going to explain you one or two questions from empirical and molecular formula. First question is: a compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Its molar mass is 98.96 gram. What are its empirical and molecular formula? Solution is, so first of all, we are making 7 columns. The first column will be of element, second column of symbol, third column percentage of element, fourth column is atomic mass of element, then fifth column is of moles of element, that is equals to percent by atomic mass. Sixth column is simplest molar ratio, and seventh and the last column is simplest whole number molar ratio, because as here it is all are whole numbers, but sometimes we are getting here in decimals and then we are converting into whole number by multiplying by suitable numbers. Okay, so first element is carbon and its symbol is C. Percentage of element is 24.27. Atomic mass is 12. Okay, so its moles of the element is, this percent of element is divided by atomic mass, and then we get 2.02. Second element is hydrogen, symbol is H, percent is 4.07, atomic mass is 1, and then mole of the element is 4.07 divided by 1 equals to 4.07. Third element is chlorine, symbol is Cl, percent of element is 71.65, and atomic mass of the element is 35.5. So mole of the element becomes 71.65 by 35.5, that is equals to 2.02. And then we are finding simplest molar ratio. Then simplest molar ratio, how to find? Out of all these moles of element you see, which is the smallest one? By that smallest one, each of the moles of the element will be divided, and that will give us simplest molar ratio. So here the smallest is 2.02. So all these 3 moles of the element is divided by 2.02. So 2.02 divided by 2.02, 1. Then again 4.07 divided by 2.02, that is 2. And again 2.02 divided by 2.02, that is 1. So just now, as I told here, all are whole numbers, but sometimes we get in decimal. Then to convert that decimal into simplest whole number, we are multiplying. But here they are all same. That's why same number we are writing, which is the simplest whole number. So this simplest whole number gives us the atomic number. That means you can say number of atoms of the empirical formula. So here carbon is 1, hydrogen is 2, chlorine is 1. So C1H2Cl1. 1 we are not writing, that's why its empirical formula becomes CH2Cl. Now we have to calculate molecular formula. For that we are calculating N. So empirical formula mass of CH2Cl is, carbon is 1, so 12 into 1 is 12. Hydrogen is 2, and its hydrogen's atomic mass is 1, so 2 into 1 is 2. Chlorine is 1 atom, so chlorine's atomic mass is 35.5, and 35.5 into 1 is 35.5, and all these three we are adding, then we get 49.5. And then N equals to molecular mass by empirical formula mass. And so molecular mass is already given to us, 98.96, that is divided by 49.5, and we get 2 approx. And therefore molecular formula equals to N into empirical formula. So N is 2, just now I calculated here, and empirical formula also we calculated, CH2Cl. So now this is multiplied So here carbon is one atom, so 1 into 2 it becomes C2. Here hydrogen is 2 atoms, so 2 into 2 it becomes 4. So and chlorine is 1, so 2 into 1 becomes 2. So C2H4Cl2. This is the molecular formula of the compound. Next, question number 2. Naturally occurring boron consists of two isotopes whose atomic masses are 10.01 and 11.01. The atomic mass of natural boron is 10.81. Calculate the percentage of each isotope in natural boron. Solution is, suppose the percentage of isotope with atomic mass 10.01 equals to X. Then percentage of isotope with atomic mass 11.01 is equals to 100 minus X. And therefore average atomic mass equals to 10.01 X plus 100 minus X into 11.01 divided by 100, because it is related to percentage and that's why divided by 100. And then we get 10.01x plus 1101 minus 11.01x by 100, that is equals to 1101 minus x by 100. This two we are subtracting and we get x. Now according to question, 1101 minus x by 100 equals to 10.81. It is given to us. And by crisscross multiplication we get 1101 minus x equals to 10.81 into 100, and this implies 1101 minus x equals to 1081, and so x is equals to 1101 plus 1000, sorry, minus 1081, and therefore x is 20. So percentage of isotope with atomic mass 10.01 is 20 and percentage of isotope with atomic mass 11.01 is 80. Thank you. If you like, please share and subscribe.